Hi, welcome everybody. I'm Aastik. I'm from ACM, and today we'll be helping you all get familiar with Flutter and get started. This name of a session is Flutter-Fly effect. As you can see, I'm Aastik. I'll be helping you with the theory portion of the event, and we have Aditi, Harshita, and Tanush who will be helping you with the code implementation. So let's get started. Uh, the basic thing in Flutter which we build upon is widget. Everything in Flutter is regarded as a widget. Each element on the screen is a widget. The view of the screen depends on the layering of the widgets and their particular attributes. Uh, the code structure is essentially a tree of widgets where one widget is inside one another. It's like a Russian nesting doll, if you will. There are two types of widgets to be exact. There's stateless widget and stateful widget. Stateless widgets are the widgets in which the state is not predefined. Uh, the only area of focus in the stateless widget is the information displayed and the user interface. They deal with situations that are independent of the user's input. State, and now to get to state is the data stored in a widget at any particular point of time. To take an example, think of a text box. A text box is a widget, and the data stored inside, the text inside it, is the state of that widget. For another example, you can think of radio boxes. The particular radio box which is selected at a time is the state of the widget. The state is telling that which radio box is selected. All right, so the state can be read synchronously when the widget is built, and we can change it during the lifetime of the widget depending on the type. The other type of widget is the stateful widget. Stateful widgets, you'll be using once you get to an advanced level, you'll be using them a lot, because stateful widgets you can you can designate the state of the widget at any given point of time. They are very useful. For example, let's think of an app where you have to change the label from welcome to please sign in. So at the beginning of the app, the state of the text field is welcome, but when you have to go to the login screen, the state changes from welcome to please sign in. That can be done through various actions and listeners and stuff. There's also another type of widget based on how many children they can have. There are single child widgets. Basically, within a single child widget, you can store just one particular child. Children is how nesting in Flutter works. Every widget has to have a child. For example, there are containers. Containers you can imagine like a box, and the object stored inside a container is its child. For example, if I have a container and I put a ball in it, the ball is the child of the container. And if I have a bigger container, I can put multiple balls in it, and those are the children of the container. So for some examples, you can see for single child widget, we have containers, center, expanded, size box. And for multi-child widgets, we have columns, rows, stacks, and list views. You will be seeing some of them in the code we are going to implement later. Then we have the widget tree. This is how the basic code in Flutter works. We have a my app, which is inherited in the second class, and there we build the material app. The material app has a attribute of my homepage, which defines the first page the app goes to when it's created. And these are the further attributes of the homepage, then scaffold, and these are the attributes of the scaffold. App bar is basically the top portion you see of the app, the one where the name of the app is usually present. And the text is an attribute of the app bar that basically asks you that what text is stored in the app bar. Center is just a centering widget. We'll talk about that in the next slide. Then there is floating action button. It's basically a small button floating in the bottom right corner, and icon is another attribute of it. So yeah, let's talk about some widgets with examples. We have center. Center is a single child widget. What it does is that whatever child you put in it, it centers it. It aligns it centrally. A very simple widget, but you'll be using it very extensively. Again, container, very simple, but you'll be using it extensively. It works like container. You can use it to separate things. You can use it to store multiple things. And it has a lot of attributes like padding. Padding defines the gap between the elements of the container. You can use align. It is also an attribute of the container where you can align the objects of the container. Then we move on to expanded. Expanded is a very useful widget for building dynamic apps. By dynamic, I mean that whenever some space is empty within the layout of the app, expanded occupies that space and helps your row and column be bigger. Then we move on to size box. Size box is very simple, yet again very useful. Size box is mostly used to define a particular size which its child cannot exceed. All right, we use sizebox like container, but we can also use sizebox for other things. For example, if we have a vertical app with a vertical layout, we can put one widget here and then another widget. And if we want some space in between them, we can just put a size box with a defined height. That puts some space between both the apps. You'll be using it a lot. Then we move on to row. Row is a multi-child widget. So usually when we define the child of a widget, within the attributes we put child. But with multi-child widgets, you put children and then you create a list. You use square rectangle brackets for creating the list, and you can hold multiple widgets in it. The use of row and column are pretty much self-explanatory. All the widgets that you put inside row, you can align them in a row, and in column you can align them in a column. Then we move on to the Navigator class. Navigator class is again very important because we often use apps that have multiple pages. So Navigator is what makes that possible. We move When we move from one page to another, most probably the code is using the Navigator class. How it works is in a stack pattern. Now, I know some of you might not be familiar with DSA, so I'll tell you stack is basically when you put objects on top of each other and you can only remove the topmost object. That is how stacks work, and that is also how Navigator is used. When you have a screen, for example, you have a homepage screen. When you change it to a login screen, the login screen is pushed onto the homepage screen. If this is the homepage screen, this is the login screen. And when the login is complete, it gets popped off and you get back to the homepage screen. And that is how Navigator works. For more complex apps, we can also design routes. We can predetermine the routes and use it more like a tree with all the routes present. It also makes the app much more optimized. Now we come to Flutter packages. Packages as you have in any other languages. For example, in Python, you have pandas and numpys. In Java, you have scanners and all. These are the basic packages that the Dart language does not provide within itself. These are the libraries that are built in that we can import to use. Most of these packages are present within the pubspec.yml file in the app. So this pubspec.yml file stores all the packages, and when we run the pubspec.yml file, all the packages are imported and they are stored within the build file. In Flutter, these packages are usually known as dependencies, and you might have heard of a lot of them. There's the splash screen. There's a popular one called Hive for local data management. There's also Firebase and Firestore that are used for making a backend. So native splash screen is one that we'll be seeing within this session itself. It's very simple. You can implement it even within a basic code with absolutely no prior knowledge of Flutter. All you have to do is create an assets folder in the app and then get your splash screen within the folder. After that, you have two options. Either you add the native splash version yourself in the pubspec.yml file, or you could go to the command line and you could simply type flutter pub add flutter native splash as is within the slide. So when you do this, it automatically adds the Flutter native splash and its version in the pubspec.yml file. So that gets imported. And when we run the dependencies to actually import them within the app itself, we use a command called flutter pubget. Once we do that, we can use the dependencies within the code. After that, within the pubspec.yml file only, to create the native splash screen, we write Flutter native splash, and in its attributes, we add the path of the background image so it knows where it can find the splash screen. After that, it's almost done. All you do is you go to the terminal, you type dart run flutter native splash create, and it creates a splash screen all by itself. This is a method that I personally like to use because it creates a really good splash screen. Plus, it waits till actually your app is done loading. That is how a splash screen is supposed to work. Some people often create splash screens that are hard coded for the time. How splash screens are needed to work is that when you open app, it requires some time for loading up, and that during that time you see a screen that is the splash screen. Some people hard code the time for that splash screen instead of actually waiting for the app to load, which can lead to glitches and errors. With this package, you don't face that problem. And I'm mostly done with the theory part, so we have Harshita who will help you with the code implementation.
Yeah. So hopefully you can see my screen and hear me. Yeah. So let's see what we are going to do in this session. So in this session, we have prepared a basic quiz app right here. It has mostly 3 screens. This is the first screen that you can see. This is the question screen. This has all the questions listed right here. It has feature of app bar. It has chips. It has a question and it has an icon right here. When you press this icon, you go to the next screen. This screen contains all the options and there is this icon to go back to the question screen. Okay. So these are all the options that are given here for the first question. When you press the right answer, you get this screen. This is a result screen which tells that you have checked the right answer. And then you go back and you get it on the first screen again. So again, also not missing this, we have this like button right here, okay, in the answer screen. So let's see the codes. So this is the code that we have made right here. These are the different files. This is the assets file where the images and the questions.json file is loaded. This is the entire data. What do I mean by the data? This means all the question, the correct answer, the options, the topic, difficulty, everything is stored here in the JSON format. Okay. Next, we have this model class. This model class, what it's doing is it's taking the data from the JSON, this file right here, this questions.json. It is taking all the data from here and then it is converting it into Dart objects. And then further, these Dart objects are converted again to JSON format. This is where all the conversion is being called. We have the screen pages right here. The first of all, we have the question screen. This question screen is for this page right here. The code is for this page right here. Okay. Then we have the answer screen. This code is done for this page right here. The answers, the correct answer and the options. Then we have a result screen. This result screen, like let's say, yeah, this one, this result screen. This code is for the result screen right here. Again, in the widget folder, we have a shape chip widget. This shape chip widget is used to call all these chips right here. You can see these chips, right? Harry Potter, easy, etc. This marks the question topic and the difficulty level. And lastly, and the most importantly, we have the main screen right here. This is where all the navigation and routes are being called. So we'll go one by one and we'll see what is happening. Okay. So first of all, again, I'll explain. Wait. Yeah. So again, this is the questions. These are all the questions stored in data format, JSON format. Okay. And just to see the criteria as topic, difficulty, question, correct answer, and the options. Okay. Next, what happens in this model class? Let's see. So this is a class model and it has its own parameters that is being called here. We have 5 parameters: topic, difficulty, question, correct answer, that are being stored as string. And then lastly, we have this list, options, which store all the options in the format of a list. Okay. We are using Dart language here. This is a constructor. It is used to initialize this class, this model right here. These functions, the model dot from JSON and this one, the to JSON one, what this one does is it converts the JSON, it calls the JSON data and it converts into Dart objects. And this one, what it does is that it takes the Dart objects that was called here and then it converts it back to the JSON format. Okay. So let's first go to the question screen. So this is the code for the question screen. This is where all the imports have occurred. Okay, these imports include the package imports and it also includes the import of the screens which we are navigating to. We have a stateful widget right here. As Aastik already explained, stateful widget handle dynamic state changes. So we have, because this is dynamic, we are navigating and all, we are using a stateful widget, okay, named by question. In this stateful widget, we have 3 functions. There is init state function, there is get question function, and then there is load question function. They are all being overridden. That means they're all being overridden in this stateful widget. Okay, so let's go to the function one by one. This init state, what it does, it acts as the entry point. What I mean by acts as the entry point, this acts as the entry point for this page to get loaded. Okay, it goes inside the state. This get question function, what it does, it is returning a future in a void. It's not really returning any data. That's why we have taken void call. It is an asynchronous call. That means it is not sequential. An asynchronous call can await or it can even delay the data. What this is doing right here, this JSON data string, it takes all the content from questions.json. Then this gets passed. Okay, it is just taking the question. It is not storing right now, returning anything. It is just getting all the questions. This load question is again another asynchronous call, and it is very similar to the previous one, get question one. But the only difference in the load question one is that it is actually storing the data in a list. Okay, again I'll show you. These were the two parameters: the questions list to store all the questions, and then there was this future list model. Okay, now we go to the UI part. This override function, this thing, what it is doing, it is returning the UI of this question page. Okay, so this scaffold widget, it acts as the skeletal of this entire page. You can see there are different parts to the scaffold widget. There is the app bar right here, the app bar for the top bar. Okay, and each app bar has its own feature: the background color, the center title, etc. These are all the parameters given to this app bar. Okay, the scaffold has different features to it. It has app bar, it has its own body. This body is the entire content that is right here. Okay, it is returning a future builder. Now again, as it was an asynchronous call, what it is calling load questions function right here. And these are the conditions given. Okay, so what happens, these, you can see the conditions right here: if the snapshot has data, or if it does not have data, etc. So let's say if snapshot has data, then it returns all the questions that are given here. If it does not have, or if there is some error, then it would display unknown error occurred. If it is in a waiting state, then it will just display circular progress indicator. For our case right here, it has all the data, and that's why it is displaying all the questions right here. Okay, now there is this next function that is being called here. This is a list view. Okay, this is a method list view, and it's getting all the questions, or all the list of the questions right here. It returns a list view builder. Now list view is used to return list, etc. But list view dot builder we use when we do not want to repeat this action. Okay, so it does it only once, and then it continues. Okay, so it has this item count parameter. It is questions was the list of all the questions that we had, and this item count takes the parameter of the length of this list. Okay, then we have the item builder, and then that inside this item builder, you can see the UI of this entire question page. First of all, we have the padding. The padding is, of course, for the padding of the page. Inside this padding, we have container. As Aastik said already, the widgets are in hierarchical form. So you'll see one widget have its own child. Okay, and depending upon whether the widget is multi-child or single child, it will have different widgets as its component. So for padding, we have a container inside here. This container right here. This one container. We are focusing on this one container. Okay. Inside this container, we have column. Why have we taken the column widget? Because it has two rows, the first row and the second row. So this column is a multi-child widget. Okay. So this is taking the first row and the second row right here. For the first row, we are returning the text of the question. Okay. See, questions index dot question. So it takes the list questions, and whatever index it is on, it calls the question parameter. See, for example, if the index is 0, then it will call this question right here, the first one. Okay, so yeah, so it is calling whatever question that we have, and this is all the text style that has been given to this text. Okay, then in this row we have the icon button. The icon button right here, what it does, it's that it navigates. Okay, so we have this on press feature. When you press the icon, the navigator is called. Okay, and this navigator that is being used to go to the answer screen, it takes in two arguments: the answers argument and the quest argument. The answers argument store the list of all the options that we have, and the arguments, this quest argument, it stores the correct answer. Okay, finally we have this next row right here. Okay, it has been aligned to the bottom left. You can see these two chips are not at the center, they're at the left side. So that is why the align widget is used for. And inside this align widget, we have again the row. And this row calls these two chips. Okay. These two chips, for the first chip indicates the topic, and the second chip indicates the difficulty level. Okay. So yeah, and this is the code for the shape chip widget. It is a very simple code. Okay, it returns a chip and it takes a label, the text label. The text label is used to identify what we are calling. We are here in this case we are calling topic, and here in this case we are calling the difficulty level. Okay, so wait a minute. Yeah. So that is all for this question page. Now this answer page will be explained by Aditi. So I'll ask her to take over.
Hi guys, welcome. I'm going to explain the answer page. Harshita, if you'd like to navigate to the answer
Yeah.
page on the emulator.
Yeah.
Okay. Off the top of your head, what are the features that you can see on these answers page? I can see an arrow on the top. I can see a couple of containers, and at the bottom I can see a like button, right? So these are the things that I can see on the screen. And this page, the answers page, has details, and it details on the functionalities of each of these things. First, let's go to the top of the code. The top of the code says class answer extends stateful widget. This answer is a stateful widget. Why is it a stateful widget? Because the content in these answers is going to change depending on which question you click. So if Harshita had clicked a different question, then the answers in this list would have been different. So that's why it's a stateful widget. And yeah. Now, this stateful widget takes in two arguments. One is the list of answers. So for every question, there are a list of answers which are displayed on the screen. You can see them in those boxes. And a string called quest. Now, the string is the correct answer, which the user doesn't know yet, but the code needs to know it because it needs to check if you're clicking the correct answer, right? And these are required arguments, which means that you have to pass these into the function. After that, we have something called as create state. Essentially, what this does is creates an answer state. Now, the answer state is basically the state of this page, and essentially, what it does it either changes the content or it will check if it's the correct answer. Okay. After that, you have the second class answer state extend state, and it has a couple of properties. One is the tile color, and second is the selected indexes. Selected indices are basically what the user will click to which it depends on which tile that you click. That's what it is. All right. And after that, we have a widget build. The widget build essentially is an overridden thing, and it basically builds the entire page. It returns a scaffold. The scaffold has a background color, and that background color has a column. Now, what is there in this column? There are three things. One is the arrow. Second is the list of answers, and third is the like button. Now, let's scroll towards the part where the arrow, the functionality of that arrow is given. When the arrow clicked, essentially, whenever you click that arrow, what it does, it does a navigator pop. What is a navigator pop? A navigator pop essentially removes, like Aastik was trying to explain that the navigator is a stack, right? So you have the current page at the top of the stack. So when you pop, you essentially pop from the stack, which is you go back to the previous page and you're not able to return to this. So that's exactly what it does. So when you click that arrow, it goes back to the previous page. Right, that's what it does, all right? And then you have expanded, which is the next, child in the column. And that goes to the function called getList, which I will explain in a while. And the last one is a container. And what is the container? That container is the like button, right? Okay, now let's talk about getList. GetList is essentially the list of all the answers for the question. So it has obviously a couple of variables, and this is a list view builder. As Harshita was talking about a list view builder in the previous page, what it does is that it avoids redundance, which is that you can call an entire list of variable length in your page. So it has a couple of parameters: item count, which is the length of the number of answers, which is that essentially what it's saying is that you should have as many answers as the number of answers for the question. Like that many widgets you should have. And then you have something called as item builder, which is that it builds the widget for each and every answer. Okay, what is the functionality of these things? One is it checks if it is the correct answer. So there's a variable here called is correct answer. And what does it check? If the index of the answer is equal to the correct answer, right? Okay. And after that, it sets a couple of other things, which is the tile color. Now, there's a ternary operator on this tile color thing, which basically says that if it is not the correct, or if it is not selected, and if it is the not the correct answer, it will have a particular color, that is lilac in this case, right? Whereas if you select it and it is the correct answer, the state of this widget will change, which is that the color of the widget will change to green, and that's what this piece of code is entailing. After that, you have some details on how the widget looks itself. So it has a height, it has a padding, it it has a tile color, and then you get to this function called on tap, right? On tap has a set state, and what the set state does essentially is it tells the widget that okay, you are changing the state of this widget. So when I click this, it changes the state of the widget, which is that it recalls the building of the widget and tells the widget that okay, the state of this has changed. So when you tap the button, if it checks if it is a correct answer, and if it is a correct answer, selected indexes adds this to its first of all, you clear the selected indexes and you add the index of whichever tile you've clicked to selected indexes. Now what this does is, if you scroll a little up into in the code, you'll see that you have a condition there which says that if selected indexes and if it is correct answer, change the color to green. So essentially you're saying that if I tap it and it's the correct answer, change the color to green. All right. And after it does this, it has a navigator push. Now, like Aastik was again detailing on how the navigator stack works. A pop is removing from the stack, a push is adding to the top of the stack. So you will add, this code is saying that it will add the result screen to the top of this stack. So whether the result is correct or not, it will add that to the top of the stack. So it will move to a next page without going back to this page. That's exactly what it says. So yeah, thank you very much. And I'll hand over to Tanush to explain the results screen.
Okay, so hello, here we are. Let's have a look at the result screen of the app. So the result screen effectively happens once you click on the correct answer. As Aditi said, it will push it on the top of the stack using the navigator. So in the result screen, we have used a scaffold. Scaffold is the basic skeleton structure for any app page. So we have aligned it to the center using aligned the column into the center. We have a sized box. Now the sized box, as Aastik said, helps you provide the spacing on the app page. So the size box of height 150 is this space here. Now, a very interesting part about this page is we have added an image to this page. So for adding an image to a Flutter application, first of all, you need to go to the pubspec.yaml file. Now, I'll speak more about this file when I cover the packages section, but right now, you need to know that once you go to the pubspec.yaml file, you go to the assets part of it. In the assets part, you need to add the path of the image that you have stored. So, for example, this image has been stored here in the assets folder, images, and the name of the image is current.png. You add the path here, and then you save the after you save the pubspec.yaml file, you call it in the image as using this function image.asset, and you add the path file. This will display an image right here, and rest of that is just basic UI elements of the text box and the size boxes. Here we have an elevated button. Now the elevated button, when pressed, again uses the navigator. Navigator again pushes the main page, the home page of the app, which is the question screen, to the top of the stack, which again shows us which takes us back to again the question space through which you can answer more questions in the app. Now, I think we are done with the theory. Let's move to something interesting. Let's make a splash screen for the app. Okay, so here I have a design of a splash screen which I made using Figma and I've imported it. Now we'll use packages in order to make this design more to inculcate this design into the app. So first of all, I'll add the dependency or the package. The package name is Flutter Native Splash. So you open the terminal and you type a very simple code, flutter pub add flutter underscore native underscore splash. After you press enter, this will automatically add this dependency into our pubspec.yaml file. So when I go here to the pubspec.yaml file, you see that this line has been added. Now, to add the splash screen to our app, we'll use this dependency in the pubspec.yaml file by implementing these two lines of code, Flutter native splash, and in the background image, we add the splash screen, which is the name of this image right here. After this, I'll just save the pubspec file and I'll go to the app and run 3 simple commands in my terminal again. So these commands are flutter clean. Okay, let it run just for a while. Flutter pub get. And now, once I run the flutter pub get, all my dependencies are back in the pubspec.yaml and pubspec.log file. Now here, I will run a very simple command, which is flutter pub run. The package is this and create. After I press this command, the package will automatically create the splash screen. Now, once we are now how the splash screen actually works in an app is it is the screen, like for example, if you're just a second, I think there has been some mess up through just the background image. Is name assets images splash screen, right? Okay, sorry, that's a typo on my part. I'm really sorry about that. Okay, again, running this program right here. Okay, so effectively, once you run this, the package will automatically code everything related to the splash screen that requires to be made. See, like you see, native splash screen complete. Now, all I'll do is I'll just go back to my emulator. I'll make sure it's not running anything, and I'll click on running the app. Okay. We are here on the debug console. Now let me explain you how the splash screen works. Now a splash screen is to be displayed when the app is loading effectively. So essentially it loads before the application and cannot be coded with the application. So what we have to do is we have to code it with the build files. Now the build files contain various dependencies containing the Dart tool folders, the Android folder, iOS folder, the Android version, the constraints on the Android version. Everything is stored in the build file, and in case of Flutter, the pubspec.yaml file. Now, when I typed those 3 commands, the pubspec.clean command deleted all the build files effectively removing all packages. So that's when you could see I had so many errors in the app. And when I typed in the command flutter pub get, this got all the dependencies present in the pubspec.yaml folder and added them to the build file. Now this effectively reduced the amount of error. Now this effectively included all the packages and all the errors suddenly disappeared. Now, since adding everything into the build file for different file folders, like if I show you my version control, these are the changes that are to be made for making one splash screen. We made the splash screen using one command. That is where the packages are very important, and they help us running lines of code in within just one or two commands itself. So let's just wait. Yeah, see, as you can see, our app has launched, and before the app loads, like the app is still loading here, the splash screen is visible. Now, once the backend of the app is ready, everything from the JSONs, the data loader, list view builders, everything is ready. That's when it goes to the real app. Okay, so I feel to sum it up, I feel that's it. We might move on to questions. If you have any, please put them in the chat. We'll be happy to answer them. guys? Do we have any questions? Okay, I feel we don't have questions as of now. So thank you guys very much for joining us. We literally enjoyed having you here, and stay tuned. We'll be taking more sessions like these. Just want to say thank you.